All right, friends. I'm going to teach you trigonometry basics. I'm Dr. UFO. I'm trying. Um, UFO stands for utterly useless fellow. My friends used to make fun of me. Anyways, I'll try to make myself useful today. Okay, trigonometry, trigonon, trigonometry. Trigonometry is one of the fascinating subjects of mathematics. It's extensively used in physics, geometry, construction. It's something to do with, it's pretty much to do with measuring areas with respect to sides of triangle. There are different ratios, yada, yada, yada. So trigonometry is derived from Greek word trigonon. Trigonon means triangle. Metron means measure. So it's all about triangles, their angles, etc. So typically a triangle A, B, C. We are considering a right angle triangle. And before jumping into complex formulas, etc., let's recall, because trigonometry is notorious for using Greek letters. Some of them are alpha, beta, gamma, theta, lambda, and a couple more, zeta, pi, kappa, and all. Now, let me briefly tell you a small analogy. So let's recall, this is a right angle triangle. Let's say this guy, his name Mr. Alpha. He visits New York City. So this is the Statue of Liberty, the Lady Liberty. Okay. And Mr. Alpha, he is amazed looking at this beautiful statue, and he wants to. It's like, he wants to see how tall is the statue. So he elevates his face, his chin. He looks up. So basically, he's looking up at an angle, say theta. So he's standing opposite to this Lady Liberty. So this side is opposite. Always opposite is a side opposite to the angle of viewing, elevation. This is angle of elevation. This is opposite. This is adjacent, and this is hypotenuse. Hypotenuse. Okay. Let's recall Pythagoras. A square plus b square equal to c square. This is famous Pythagoras theorem. Hypotenuse square is opposite square plus adjacent square. Let's rephrase this and use it like this. Hypotenuse square equal to opposite square plus adjacent square. This is Pythagoras theorem, but it's more descriptive because a square plus b square equal to c square, you have to again emphasize what is a, what is b, what is c. Rather than that, if you use this hypotenuse square equal to opposite square plus adjacent square, this is very, very descriptive. Okay. Now, in trigonometry is all about ratios and angles with respect to a triangle. Now, so they define certain ratios. Say for an example, sine theta. Sine theta is a ratio of opposite over hypotenuse. Opposite over hypotenuse. Likewise, cos theta is adjacent over hypotenuse. So I'm going to put everything in a grid so that you can easily remember. Okay, sin theta. Sin theta is opposite over hypotenuse. Cos theta adjacent over hypotenuse. And tan theta. Tan theta is basically ratio of sin theta and cos theta. Sin theta divided by cos theta. Remember this. When you divide these in terms of the sides, it becomes, and I'm going to do it on the side, a little bit of algebra. Opposite over hyp divided by adjacent over hyp. Okay, these two cancel off. How do they cancel off? It's basic fractions. Say for an example, a fraction 5 by 4 divided by 7 by 4. You can rewrite this fraction as 5 by 4 times 4 by 7. This flips when it goes up. 4 by 7. So it's 4 cancel. 5 by 7. So in a nutshell, opposite over hypotenuse, adjacent over hypotenuse, hypotenuse cancel off. So opposite over adjacent. Tan theta is a ratio of sine over cos, which comes down to opposite over adjacent. Sine, cos, tan. Okay, it doesn't stop here. They gave ratios, it's fancy names for the reciprocals. You know what a reciprocal is? Reciprocal of P is 1 over P. Reciprocal of 5 over 4. What is the reciprocal of 5 over 4? 1 over 5 over 4. Which is 4 over 5. Just remember this. So they gave a fancy name for reciprocals too. So reciprocal of sine theta is called cosecant theta. Cosecant theta is 1 over sine theta, which is equal to hypotenuse over opposite. Okay. I'm going to squeeze here. Now, also, likewise, reciprocal of cos theta is secant theta. Secant theta is reciprocal of cos theta, which is equal to hyp over adjacent. Now tan theta. Reciprocal of tan theta is called as cot theta. Cot theta is reciprocal of tan theta. In terms of the side, it will become adjacent over opposite. I know it's little complex to comprehend all these, but you have to, I would suggest practice it a little bit, write it a couple times, and just memorize it. There is a mnemonic to remember, SOHCAHTOA. SOHCAHTOA is sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. But I would spend some time and just memorize this, because again, going back to SOHCAHTOA, you have to put the entire thing in phrase and decipher what is S, what is O, what is H. I would just memorize this, because this thing is extensively used in calculus, geometry. Believe me, certain problems of geometry you can easily solve in trigonometry. Some complex geometry problems you can be done quite easily. I can give some examples later part. Okay, now let's go back and rewrite the Pythagoras theorem. The famous Pythagoras theorem is opposite square plus adjacent square equal to hypotenuse square. Now we're going to tinker with this. We're going to play around. This is basically a simple equation. So we're going to rephrase this in different lingo. Now let's recall what's the definition of sine theta. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Now I'm going to cross multiply. I will write opposite. I'll express opposite in terms of sine. So I can fairly rephrase this as opposite equal to this cross multiplies, right? Bring it here. This multiply. Sine theta times hyp. Likewise, adjacent will be cos theta times hyp. This is all basic algebra. You should be able to easily do this. If you are I have a tutorial which teaches you solving simple complex linear equations. I will put something in future. Now these guys I'm going to substitute here in this equation, and let's see what happens. Instead of opposite square, I will write it, I'll express sine theta times hypotenuse. Basically what we're doing here is solving simultaneous equation via substitution. So opposite square is sine theta times hyp whole square. Now adjacent square is cos theta times hyp whole square. This is equal to hyp square. So this is square. I'm not doing anything fancy, just basic algebra. From here on I'm going to go a little faster. So this is sine square theta hyp square plus cos square theta hyp square equal to hyp square. I'm going to take greatest common factor, which is hyp square is hyp square. So we get sine square theta plus cos square theta equal to hyp square. The moment you see something like this, you fancy dividing with hyp square. So they cancel off. So we are left with sine square theta plus cos square theta equal to 1. Okay, what is this? This is again nothing but a fancy way of saying Pythagoras. This is a Pythagoras theorem, but in terms of the ratio, sine and cos. Okay, this formula I would rather by heart it. Why? Because its applications are enormous basically. You'll be using lots of problems solving uses. Okay, and you can play around with this because sine square theta plus cos square theta is 1. Right? I'm going to move things around and express this same equation in different forms. So like, see, I can fairly say sine square theta is 1 minus cos square theta. Likewise, cos square theta is 1 minus sine square theta. This also you have to remember this. Okay, it doesn't stop here. So go back. Algebra you have to be extremely very strong in order to solve complex mathematics. You have to be very good at algebra. Now let's go back. Recall very famous formulas of algebra. A square minus b square as factors. A square minus b square is a plus b times a minus b. This is important. Basically what it means is when you multiply a plus b times a minus b, we get a square minus b square, because plus ab minus ab cancel off. This and this, a plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. All these formulas you should remember, because we don't know when we apply these. I'll show some of the examples how these little formulas are applied in trigonometry. Now let's stop here. Okay, sine square theta. Why I was emphasizing about a square minus b square, a plus b. See, whenever you see something like this, a square minus b square, says here sine square theta equal to 1 minus cos square theta. 1 you can write it as 1 square. So this is like it's in a form of a square minus b square. So you can fairly express this as a factors. This is 1 minus cos theta times 1 plus cos theta. Likewise, cos square theta is 1 plus sine theta times 1 minus sine theta. So I hope I'm not confusing. This is all basic algebra. So I'm just trying to illustrate how algebra is used in trigonometry. Okay, let's go back. I'm going to rewrite this equation again. Sine square theta plus cos square theta is 1. Now, I am feeling itchy to express this in terms of tan. Let's see what happens. How do I get tan? Go back and recall what is tan theta. Tan theta is sine theta over cos theta. Okay, let me tell you. Whenever you square a trigonometric ratio, tan theta whole square, you don't write it as tan square theta square. Basically, what it means is, because it's a ratio, tan theta is a ratio, when you square it, you express this as tan square theta. Say if I cube a secant theta whole cube, this means you express this as secant cube theta. You don't write it as secant cube theta cube. Okay, remember this. Okay, now I'm going back to this Pythagoras theorem. Sine square theta plus cos square theta is 1. Now I like to divide. I just want to see what happens if I divide with cos square theta. If I divide with cos square theta, so basically it's a partial fraction, you split it across. Sine square theta divided by cos square theta. Cos square theta divided by cos square theta equal to 1 by cos square theta. Correct? These two cancel off. Sine over cos. Go back, recall what sine over cos. Sine over cos is tan. So this is tan square theta plus 1 equal to 1 over reciprocal of cos. 1 over cos is secant square theta. So now we're going to box this guy. Remember, it's 1 plus tan square theta is secant square theta. Oh, and also we can tinker with this. We can fairly write secant square theta minus tan square theta is 1. Wow, this is nice. And whenever you see a square minus b square, we can always write it as a plus b times a minus b. So this is secant theta plus tan theta times secant theta minus tan theta equal to 1. Remember this. You don't have to memorize this, but it's most of the times whenever you express something square minus something square, you rephrase this as a plus b times a minus b, because especially some of the problems they ask you. Okay, now this equation here, let me underline this equation here, right? We divided with cos square theta. Let's see Likewise, you pause the video, divide with sine square theta and see what happens. Okay? When you divide with sine square theta on both sides, we end up with similar to this, but like this. 1 plus cot square theta equal to cosecant square theta. And likewise, we can write all these. So I'm going to put all these little formulas in a grid, in a box. Let's come back. Okay. First of all, the Pythagoras, sine square theta plus cos square theta equal to 1. I can rephrase this. 1 minus sine square theta equal to cos square theta. 1 minus cos square theta equal to sine square theta. Remember this. Okay. Now 1 plus tan square theta equal to secant square theta. Right? Secant square theta minus tan square theta equal to 1. Right? Okay, this is enough, I think. And you can, obviously this a square minus b square, you can write as secant theta plus tan theta times secant theta minus tan theta. I'm going to use a red pen. Now, likewise, 1 plus cot square theta is cosecant square theta. Cosecant square theta minus cot square theta is 1. Right? Obviously, a plus b times a minus b. You can express that. Cosecant theta plus cot theta times cosecant theta minus cot theta. Got it? Okay. I'm going to solve a couple problems using all these basic formulas. Okay. Before going there, let's go back to basic understanding of sine theta. As I've told you, I went quickly. Sine theta. What is sine theta again? It's a ratio between opposite over hypotenuse. In this applied obviously to a right angle triangle, remember. Now, can you imagine what will be the maximum value of sine theta? Because sine theta is a ratio, sine theta equal to opposite over hypotenuse. Maximum value of sine theta is 1. Why? See, obviously, this is a ratio. Hypotenuse can never be more than opposite, right? Because it's the ratio. Say, for an example, opposite is 4. Hypotenuse has to be more than 4 at most. I mean, has to be, typically it's the longest side, right? Has to be more than 4. So say 4 by 5. Is it possible that hypotenuse will become equal to opposite? You can imagine like this, right? Imagine this is the theta. Now imagine the theta is becoming larger and larger and larger. Like, so that the triangle would look like this. Now this theta is probably like 85 degrees or something. As the theta increases, approaches, as theta tends to 90 degrees, as approaches 90 degrees, this hypotenuse and opposite becomes equal. So at 90 degrees, they are equal, something like that. So imagine, so maximum value of sine theta is 1. So sine 90 is 1. So sine theta, when you plot, it looks like a curve. This is when you graph it. The maximum value of sine theta is positive 1, minimum is negative 1. And it fluctuates, basically it bombards between 1 and negative 1. Okay, now one more thing is, this constant for certain angles, the standard angles like 0, 30, 45, they give ratios. I would memorize this. I would not rely on calculator to basic ratios, because it's weights little faster. So I'm going to chart a table, the standard ratios, the values. So sine theta, cos theta, tan theta. This is the angle values in degrees. 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Sine 0 is 0. Sine 30, half. 45, root 2. Sine 60, root 3 by 2. Sine 90, 1. Cos 0 typically is backwards. Cos 0 is 1. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Cos 60 is half. Cos 90 is 0. Because the sine is reciprocal of sine over cos, 0 over 1 is 0. This is 1 by root 3. 1 root 3. 1 by 0 is undefined in A. I would take some time, pause the video, write on a cheat sheet or index cards, and simply memorize this. This will help you. Don't rely on calculators for now. Now, let's solve some basic problems, like, derivations of something. Okay. I'm going to give some basic trigonometric problems, and also I'll explain you how to approach and attempt it. Okay. Remember a couple things, right? As I've told you, reciprocal. Tan theta and cot theta are reciprocal of each other. So when you multiply and tan and cot, they kind of like cancel off each other. Tan theta times cot theta is always 1, because cot theta is 1 by tan theta, right? They are reciprocal of each other. Tan theta, cot theta you express as 1 by tan theta. They cancel off. Remember, a product of tan and cot is 1. Product of sine and cosecant is 1. Sine theta times cosecant theta is 1. Likewise, I've been using theta all the time. Let me just use some other Greek letter. Okay. Now, cos alpha times secant alpha is 1, because they are reciprocal of each other. Okay. Now, let me solve some basic problems. Okay. Now, say for an example, somebody is asking you this question: sine theta plus cos theta whole square plus sine theta minus cos theta whole square. Wow. So, if you look closely, this is more of algebra question than trigonometry. He's asking you what is a plus b whole square plus a minus b whole square. Go back and recall what is a plus b whole square. That's an expansion. A square plus 2ab plus b square. Excuse my handwriting. So a plus b, pretend this is a and this is b. When you expand, it becomes a square plus b square plus 2ab. Alright, and you expand this fella, a minus b whole square, a square plus b square minus 2ab. Now, if you look closely, plus 2 sine theta minus 2 sine theta, they kind of negate each other, they cancel off. Now, what you end up with? Sine square theta plus cos square theta. What is sine square theta plus cos square theta? Recall the formula. Sine square theta plus cos square theta is 1. This is sine square theta plus cos square theta is 1. 1 plus 1 is 2. Answer is 2. Okay, let me tell you a trick and you can remember this trick. Always remember, right? Whenever you do this algebra, basic algebra again, a plus b whole square plus a minus b whole square. Just memorize this. 2 times a square plus b square. And likewise, this will, believe me, this will, especially in SAT, some of the competitive exams, they tinker a lot with these kind of questions. You don't need to put your pen on the paper. You just can do without even solving it and do it in your mind. 2 times a square plus b square. I'll give you an example, say. Okay, likewise, a plus b whole square minus a minus b whole square is basically a plus a square b square, they cancel out. We'll end up with 4ab. Okay. Now I'm going to solve a problem using this and trigonometry, and you'll be amazed how we solve this, how this formula is going to help you. Okay, here I give one more problem here. Okay, here tan theta plus cot theta whole square minus tan theta minus cot theta whole square. So what we're doing here, a plus b whole square minus a minus b whole square. A plus b whole square minus a minus b whole square is basically 4ab. So you don't need to physically expand this, just remember this, 4ab. 4 times a times b. But what do we know with tan and cot? When they come together, they kind of like cancel off each other. I wouldn't say they kill each other, they just cancel off each other. They cancel off each other. So answer is 4. Okay, you can expect lots and lots of trigonometry problems, especially using the above 2 formulas, and it'll be very, very helpful. Okay, let me end this chapter here. I am going to post a couple more tutorials and I will solve lots of problems. I hope I tried to make myself clear. But in the meantime, I would rather suggest you to memorize, write down an index card, memorize whatever you studied, not just blindly memorizing. Understand how we derived the basic trigonometry, Pythagoras, and how we tinkered dividing with and getting various forms of other formulas. Thank you.